So a function which is both 1, 1 and onto is said to be a bijective function. A function f from a to b is said to be invertible if there exists a function g from b to a such that g naught f and f naught g are identity function. F from minus 1 comma 1 to r is given by the function f of x is equal to x by x plus 2 is bijective. F of x1 is equal to f of x2 implies x1 is equal to x2, therefore f of x is an 1, 1 function. Hello dear students, welcome to this session of Mathematical and Statistical Computing class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. So in my previous class, we have discussed regarding types of functions and the problems. Today in this session also, I am going to discuss regarding some types of functions and the invertible function. So a function which is both 1, 1 and onto is said to be a bijective function. If a function is bijective, then it is called an invertible function. For an invertible function, it must be 1, 1 and onto function. Now let us discuss a function which gives the same value as inputted, that is f of x is equal to x, is called an identity function. Now a function, let us know regarding an identity function. Identity function means f of x is equal to x. A function which gives the same value as inputted is called an identity function, denoted as f of x is equal to x. So identity function of GOP and FOG. If f from a to b and g from b to a, then GOP of x to x is identity function on x and it is denoted as GOP of x is equal to I of x. And similarly, f naught g of a function f naught g from y to y is identity function on y if it is f naught g is equal to I of y. So if g naught f GOP is equal to ix and FOG is equal to iy, then it is called an identity function. Let us move on to the next very important concept, that is invertible function. A function f from a to b is said to be invertible function if there exists a function g from b to a such that GOP and FOG are identity. So GOP and FOG are identity, then it is called an invertible function. That is, a function f from a to b is said to be invertible if there exists a function g from b to a such that g naught f and f naught g are identity function, right? Or the function g is called the inverse of f and it is denoted as f inverse is equal to g. This is one definition. Or another definition is, a function f of x is invertible if f of x is both 1, 1 and onto. A function f of x is both 1, 1 and onto. That means if it is a bijective function. If it is bijective, then it is a invertible function. We can find the inverse, and the inverse of this function is denoted as f inverse. That's it. These are the two methods to find the inverse of a given function. Okay. Now take an example. So this is a 6 or 7 mark question. You may expect this type of questions in your final examination. Consider f from R to R given by f of x is equal to 4x plus 3. Show that f is invertible. Find the inverse of f. Very important problem for the point of examination. What is given? F of x is equal to 4x plus 3. Now first verify whether it is 1, 1 or not. 1, 1 function. Now let for all x1 comma x2 belongs to x, then f of x1 is equal to f of x2 implies, what is f of x1? 4x1 plus 3 is equal to 4x2 plus 3. Transfer this plus 3, it becomes minus 3, plus 3 gets cancelled. You will get 4x1 is equal to 4x2. Divide by 4, then this becomes x1 is equal to x2. What is the meaning? So f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, f of x is 1, 1 function. F of x is 1, 1. So first part of the problem. Now second, verify whether it is an onto or not. Now to verify onto function, let, what is the condition? Let for all y belongs to y, there exists f of x is equal to y, such that f of x is equal to y. Now what is f of x? F of x is 4x plus 3 is equal to y. 4x is equal to y minus 3. X is equal to y minus 3 by 4 belongs to R. Now what is this? Since f of x, just find out f of x. What is f of x? Since the given value of x is f of x is equal to 4x plus 3. Now instead of x, substitute here y minus 3 divided by 4. This is equal to 4 into x is nothing but y minus 3 by 4 plus 3. Just replace x by y minus 3 by 4. So this 4 and 4 gets cancelled. What is this equal to? Y minus 3 plus 3. That's equal to minus y plus minus 3 plus 3 gets cancelled y. So we got f of x is equal to y belongs to R. Therefore f of x is onto function. That's it. F of x is an onto. So this condition is satisfied. F of x is equal to y. Therefore it is an onto function. Since f of x is both 1 1 and onto, 1 1 and onto, therefore it is invertible. This is invertible. Now to find the inverse, let f inverse of x is equal to y, which implies f of y is equal to x. F of y is equal to x. Right. So what is f of y? Since f of x is equal to 4x plus 3, f of y can be written as 4y plus 3 is equal to x. So 4y is equal to x minus 3. Y is equal to x minus 3 by 4. What is y? Y is nothing but f inverse of x. So therefore f inverse of x is equal to x minus 3 by 4 is the inverse. So the final answer is f inverse of x is equal to x minus 3 divided by 4. That's it. F inverse of x is x minus 3 by 4. This is how we are going to solve this problem. Very important for the point of examination. You may expect this type of question for 5 or 6 marks. Right. Now move on to the next problem. This is an important problem. Show that f from closed interval minus 1 to 1 to r, f from minus 1 comma 1 to r is given by the function f of x is equal to x by x plus 2 is bijective. Find the inverse of the function. So here very simple, same as that of the previous one. To verify whether it is a bijective or not, just verify whether it is 1 1 and onto. If it is 1 1 and onto, invertible function, that is bijective function. So inverse exists. Just verify 1 1 function first. Now first one, to verify 1 1. Now, so what is given? Given f of x is equal to x by x plus 2. Now f of x1, consider f of x1 is equal to f of x2. What is x1? F of x1 is x1 divided by x1 plus 2 is equal to f of x2 is x2 divided by x2 plus 2. Cross multiply and simplify. X1 into x2 plus 2 is equal to x2 into x1 plus 2. Now, just this is equal to multiply x1 into x2, x1, x2 plus 2 into x1 is 2x1 is equal to, similarly on the right hand side, x1 into x2, this is x1, x2 plus 2x2, 2s2. Just bring this to the left hand side, x1, x2 plus 2x1 minus x1, x2 minus 2x2 is equal to 0. So minus x1, x2 plus x1, x2 gets cancelled. What is left over is 2x1 minus 2x2. Transfer to the right hand side. This becomes 2x1 is equal to 2x2. Divide by 2, which implies x1 is equal to x2. That means f of x1 is equal to f of x2 implies x1 is equal to x2. x1 is equal to x2. That is, therefore, f of x is 1 1 function. Okay. f of x is 1, 1. Okay. If f of x1 is equal to f of x2 implies x1 is equal to x2, then f of x is 1, 1 function. Now, first part is finished. Now, verify whether it is onto or not. Now, just to verify onto, let for all y belongs to y, there exists f of x is equal to y. Right. Now, what is f of x is equal to y belongs to R. Now, f of x is equal to y means x divided by, what is given problem? X divided by x plus 2 is equal to y. Just cross multiply, this is y into x plus 2, x is equal to xy plus 2y. Bring this to the left hand side, x minus xy is equal to 2y. Take x common factor, then this becomes 1 minus y is equal to 2y. Therefore, x is equal to 2y divided by 1 minus y. Okay, so such that f of x is equal to f of, what is x? X is nothing but 2y divided by 1 minus y is equal to, substitute here. So, what is f of x? F of x is x by x plus 2, put instead of x this one, 2y divided by 1 minus y whole divided by 2y divided by 1 minus y plus 2. Take LCM in the numerator, 2y divided by 1 minus y as it is. In the denominator, 1 minus y is the LCM, 2y plus cross multiply, 2 into 1 is 2 minus 2y. So, what happens? 1 minus y gets cancelled, plus 2y minus 2y gets cancelled. In the numerator, 2y divided by 2 gets cancelled. This is equal to y. So, f of x is equal to y. That means, what is the conclusion? Therefore, f of x is onto function. F of x is onto. So, what is to verify here? Show that is bijective. Find the inverse. So, therefore, f of x is bijective. F of x is bijective because it is both 1, 1 and onto. 1, 1 and onto. Right. To find f inverse, let f inverse of x is equal to y, which implies f of y is equal to x. What is f of x? F of x is equal to x divided by x plus 2. Instead of y, it is y divided by y plus 2 is equal to x. Cross multiply, y is equal to x into y plus 2. This is nothing but xy plus 2x. Now, just bring this to the left hand side. Y minus xy is equal to 2x. Now, you can take y common factor. 1 minus x is equal to 2x. So, therefore, y is equal to 2x divided by 1 minus x, which belongs to R. Now, what is y? Y is nothing but f inverse of x. So, therefore, y is nothing but f inverse of x is equal to 2x divided by 1 minus x, which is the inverse of the given function. So, f inverse of x is equal to x divided by 1 minus x. That's it. Hope you followed. Okay, just recall this. Let me repeat. So, just find out f of x is 1, 1. For 1, 1, f of x is equal to f of x1 is equal to f of x2 implies x1 divided by x1 plus 2 is equal to x2 by x2 plus 2. Cross multiply, x1 into x2 plus 2 is equal to x2 into x1 plus. Simplify. What happens? X1, x2 plus and minus gets cancelled. F of 2x1 minus 2x2 is equal to 0 implies 2x1 is equal to 2x2 divided by 2, x1 is equal to x2. That means f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, f of x is an 1, 1 function. First part. And the second part, just verify onto. To verify f of x is an onto, let f of x is equal to y. What is f of x? X by x plus 2 is equal to y. Cross multiply and get the value of x. X is equal to y into x plus 2. xy plus 2y. Bring this to the left hand side. X minus xy is equal to 2y. X is a common factor. X into 1 minus y is equal to 2y. Therefore, x is equal to 2y by 1 minus y. Such that f of x is equal to, f of x is nothing but 2y divided by 1 minus y. Substitute here. Instead of x, put 2y by 1 minus y. 2y by 1 minus y divided by x is 2y by 1 minus y plus 2. Take LCM. 1 minus y is the LCM. Numerator is same. So this 2 minus 2y plus 2y gets cancelled. 1 minus y in the denominator, numerator gets cancelled. 2y divided by 2, 2 gets cancelled. That's equal to y. That means f of x is equal to y. So hence f of x is an onto function. So therefore f of x is a bijective function because it is both 1, 1 and a onto function. Now to find the f inverse, let f inverse of x is equal to y. So just f inverse x is equal to y implies f of y is equal to x. What is f of y? Y by y plus 2 is equal to x. Cross multiply y into y is equal to x into y plus 2. Multiply xy plus 2x. Just bring this to the left hand side. Y minus xy is equal to 2x. So you can take y common factor. Y into 1 minus x is equal to 2x. Y is equal to 2x by 1 minus x belongs to R. So that means here f of x R belongs to f, right? So belongs to the given function. So therefore f inverse of the function is given by f inverse of x is equal to 2x divided by 1 minus x. That's it. Hope you followed. So these type of problems are very important. You may expect this question for your final examination. Hope you followed. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.